Last class, we briefly began talking about combining like terms. Today, we're going to talk more about combining like terms in greater detail. So before we get started, I want you to be fully aware that your video is in two parts today. Part one is on this worksheet, which you should have in front of you. If you do not have this worksheet in front of you, I need you to pause this video and I need you to get it out. You'll be following along with this video with this worksheet. So if you don't have it, pause the video, find it. Remember, it's on the back of a piece of paper. It should be in your notes section from last class. The second page of your notes, so the second video, is going to be on a piece of paper that you write yourself. So when we finish this video, you're going to get out a piece of loose leaf paper and you're going to follow along by copying the notes down that I present on the board. One thing I want to mention, remember we are using color coding techniques as we get through this project, as we get through these notes. When you have to hand write them, when you see me on the board write in color, I'm going to write, that means you write in color. And when I write in black, that means you write in black. Okay? So if you have any questions, make sure that you clarify before you keep going. Otherwise, we are going to go ahead and get started. So last class, we talked about this whole side that is being shown right now on the board. So we talked about combining like terms. Our goal was to simplify. Remember we mentioned the word simplify, and we said simplify means to make simpler. So my goal is to make a problem look simpler. Okay? And when I'm doing that, I have to be able to understand what the words combining like terms actually mean. Remember last class we talked about that the word combining just means to add. Then last class we talked about what the word terms was. So if I just really quickly review what the word terms was, remember term is one of four things. It can be a number, it can be a variable, it can be a product, or it can be a quotient. Remember I mentioned that terms are always separated by a plus or minus sign. So if I look at these examples, 1, 2, 3, and 4, and we did one very quickly last class, so if we do it a little bit more, how I separate my terms is I draw slashes before every plus sign and every minus sign. So if I draw a slash before every plus sign and every minus sign, I'm going to notice I have 7x, negative 4y, and 5. So notice I have 3 terms. Okay? Notice 7x is considered a product because it's 7 times x. Negative 4y is also a product because it's negative 4 times y. And 5 is just simply a number. So the reason why we draw slashes is because it's going to make our lives so much easier when we actually get to the fun part of combining them. So if we look at number 2, I'm going to determine the number of terms. So I'm going to draw a slash before every plus sign and every minus sign. And why I draw my slashes is so I can see when my minus signs turn to negatives. It makes my life a little easier. So notice I have 9x squared, negative 3x, x over 2, and negative 1. So I have 4 terms. Okay, 9x squared is classified as a product. Negative 3x is considered a product. X over 2 is considered a quotient. And negative 1 is considered a number. So go ahead real quick, pause this video, and I want you to do 3 and 4 on your own, and then unpause the video for me, please. So hopefully number 3 you said had 3 terms. Because if I draw my slashes, 1, 2, 3. And number 4 has 1, 2, 3, 4, 5 terms. So with the words combining like terms, I know combining means to add, and I now know how to determine my number of terms. So now I need to talk about, well, what's a like term? That's the hardest part, is determining what a like term is. So we're going to take a nice segue here. I'm going to move this over here, and I'm going to hope I don't mess this up because we all know how great I am with technology. So if I pull this picture up, this is my dream McDonald's order. I am going to McDonald's and I am so hungry that I'm going to order all of this food. I'm not going to share it with anybody. I might then gain 500 pounds. However, it'll be worth it. So, this is if we look, this is a hamburger or a cheeseburger, whatever you want to call it. I'm going to call it a hamburger. This is chicken nuggets. This is a McChicken. Small fry, medium drink, large drink. Okay, just so we all know. So this is the order that I've gathered that I'm going to take to McDonald's to order everything that I want. So, if I go up to the cashier in line for McDonald's and I order my food and I go, I want a hamburger, I want some chicken nuggets, I want a McChicken, I want a small fry, I want a large fry, I want a medium drink, I want a large drink, I want a hamburger, I want a chicken nuggets, I want a chicken nuggets, I want a large fry, 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 I want a medium drink. You think they're going to think I'm insane? Hopefully you're listening to this thinking I'm insane. But yes, they're going to think you're absolutely crazy. So, this relates to like terms. So when we're talking about ordering an item at a cashier, how could I condense this? Well, I noticed that I have 2 hamburgers. One here and one here. And I know, so I have 2 hamburgers. I'm going to say 2H. And I have 1, 2, 3 chicken nuggets. So that's, oops, I don't even have to do that. And I have 3 chicken nuggets. And I have 1 McChicken. And I have 1 small fry, because you only go there for the small fries, or for the fries, period. And then I have 1, 2, 3, 4, 5 medium French fries. So 5 French fries. And then I have 2 medium drinks, so 2 drinks. And I have 1 large drink. Okay, so I can put the ones in front of the McChicken and in front of the large drink. Okay. So now, if I were to go to the cashier and go, I want 2 hamburgers, 3 chicken nuggets, 1 McChicken, 1 small fry, 5 medium fries, 2 medium drinks, and 1 large drink. 1, they're going to think I'm a pig, but 2, they're not going to think I'm as crazy, right? Because I've condensed it. I've combined the terms that are like, okay? So, that also goes for the things that I don't order. So if I look on this menu, what did I not order? I didn't order a McFlurry, right? So I'm not going to go to McDonald's and I'm not going to say, I want to order all of this food, but I want 0 McFlurries. Are you going to sit there and tell them everything you don't want, or are you going to tell them everything you do want? Are you going to tell them everything you do want? So you never have to include the things that you don't want, okay? So this ties back into what a like term is. So hopefully I now just made you all really hungry and wanting McDonald's. You're welcome. So, if we talk about what a like term is, a like term has 2 conditions. Condition 1 is it has to have the same variable. Okay? And condition 2 is the exponent. The exponent must be the same. So if I go back, and again, the nice thing about this video is you can pause it at any time if I didn't, I'm not giving you enough time. If I go back to my McDonald's picture, can I say if I order, and I'm going to highlight in circle in green, I'm going to order French fries, right? So my French fries, I'm ordering 1 small and 5 medium, right? If I go to the cashier and I go, I want 6 medium French fries, does that clearly depict what I circled in green? No. I can't combine a small French fry with a medium French fry because they're not the same size. Okay, my next question, if I circle in blue, if I say I want a hamburger and a McChicken, if I say I want a hamburger and I want chicken nuggets, and they produce me a McChicken, can I do that? No, I can't add a hamburger and chicken nuggets and get something different. They're very different food items. I have to keep them separate. So if we go back over here, it has to have the same variable. So I can only add x with x and y with y. Okay? And the exponents, meaning the size, also has to be the same. So if we come down and we look at these examples, can we combine the following? We're either going to put a check or we're going to put an X. So X and 2X, am I allowed to combine them? Well, let's look. This one has an X. Does that one have an X? Yes. Are their X's the same size? Meaning, do they have the same exponent? Yes, so I can combine them. Smiley face and a frowny face. Can I combine them? Nope. One's happy, one's sad. They're not the same. I can't combine them. Two different symbols. 7x squared and 3y squared. So they're the same size, but are the variables the same? Nope. So I can't add them. That's like saying this is a medium French fry and this is a medium drink. I can't add medium French fries and medium drinks together, so I leave it alone. How about 3a squared and negative 7a squared? So the variables are the same. Check. Exponents are the same. Check. So yes, I can combine them. Okay? So, big question of the day. How do we combine them? Right? So let's go all the way back up to the top here. Let's look at our heading. Combining like terms. So I know combining means to add. Like terms, I now know. They're variables that have the same letter, that are the same size, meaning exponent. So, how do I combine them? All I do is add the coefficients of like terms. That's all I'm going to do. I'm going to add the coefficients of like terms. Okay. So, how I do this. Every teacher teaches this a bunch of different ways. I teach it maybe a little differently. If your teacher last year taught it differently, great. You're going to do it that way if you like that way better. You might like my way better. So, when I'm simplifying these, first off, look at your problem. If you look at your problem, can I follow PEMDAS to solve? No, because I don't know what x equals. So the only way I can do this is combine like terms. So how I do this is I'm going to draw slashes like I did at the beginning of the paper. I'm going to separate all my plus signs and all my minus signs so I can separate all of my terms. So notice I have 3 terms. So now I'm going to look at 4x. 4x. Can I add 4x with 9x? Well, yes, I can, because they both have an x, and they have that x is the same size. So all I'm going to do is add the coefficients, so the numbers in front. So 4 plus 9, 13. So I have 13x. Now I have a plus 6. So 6 I'm just going to bring down, and now we're going to talk about it. Can I add 13x with 6 and make 19x? Hopefully you're all shouting at me no, because 13 has an x, but 6 does not. So, I'm done. Hopefully you're doing all right. Let's look at number 2. I'm going to draw slashes, first thing, before every plus sign and every minus sign. So now I'm going to look at 3x squared. 3x squared. Look at the next term. I'm going to combine it with negative 2x squared. 3x squared and negative 2x squared make 3 and negative 2 make 1. So 1x squared. And then I cross these out so my brain knows where they are. 4x can be combined. Can that be combined with negative 2x? Yes. Why? Because they both have the same letter, x, and they're the same size. So 4x and negative 2x, 4 and negative 2 make positive 2x. Don't forget your variable. It's like when you go up to McDonald's and go, hello, I'd like 2, please. They're going to look at you like you're crazy. 2 what? Cross them out because I used it. 8, can I combine that with anybody? No. I know I'm done because I can't combine anybody with anything else. I can't combine x squared with x because that's like saying medium and this is like saying small. There's one last thing I could technically change on my answer that I just circled. See how that says 1x squared? What's another way I could do that? I could just say x squared plus 2x plus 8 and be done. All right, let's go ahead and do one more together. So first thing I'm going to do when I have to combine like terms, I'm going to draw my slashes. So now I'm going to look. 2m. Can I combine 2m with 3m squared? No, because one has an m and one has an m squared. They're not like terms. Can I combine 2m with negative 4m? Yes, because the variable is the same and they're the same size. 2 and negative 4, add them up, make negative 2m. Remember, you're always adding these problems. 3m squared, can I do that? Combine that with anybody else? No. It does not really matter what answer goes where, as long as it's in this, you have the right numbers. As long as 2m is negative and 3m squared is positive, that's all I care about. Okay? So I want you to go ahead and I want you to pause this video and I want you to try 4, 5, and 6 on your own. When you finish the video, I want you to unpause and the answers will be on the screen. So I went ahead and I put up the answer to number 5. Hopefully you don't have any questions with that number. I'm sorry, number 4. But you could also rewrite this as 16n minus 4n squared plus 1. It really doesn't matter which way, as long as 4n squared is negative, 16n is positive, and 1 is positive. I did want to mention about number 5, though. Notice 4xy and 2xy I underlined. I can add those together because they both have an x and a y. So 4xy and 2xy make 6xy plus x. Can I add x with 6xy? No, because there is no, this term here does not have a y. And then I went ahead and I put up the answer to number 6. So if you're ready to go, you're going to get out a separate sheet of paper, so a piece of loose leaf paper. Remember, I have lots of loose leaf paper in my bookshelf if you need it. So you can do part 2 of this video, which is where you're going to click it on Google Classroom.